Hello everyone, I'm Mauricio Velazco, and in this session I'll be introducing you to PurpleSharp, an adversary simulation tool that detection or blue teams can use to build, test, and enhance detection controls. So my goal for this session is to first introduce the tool, the challenges it tries to address, and why it's different from other tools. After that, we will go over 25 minutes of demos to show you how PurpleSharp works in action. First is the Who Am I section real quick. Like I said, I'm Mauricio Velasco. I'm originally from Arequipa, Peru. That's a picture of my home city. I started my career as a pen tester more than 10 years ago, and then moved to the blue team a few years ago. I currently lead the threat management team at a Fortune 500 organization in the financial services space. My team does, among many other things, detection response and simulation as well. I'm on Twitter. That's my Twitter account. I always love to connect and meet new people. For the past few years, I've done some talks and research around threat hunting and detection and simulation. So if you're interested of any of that, visit my GitHub page where you'll find some content. So first, I want to start talking about a common challenge for detection teams. So in this diagram, we can look at what a detection program looks like at a high level. You know, you have different data sources like endpoints, network systems, servers, applications. They're all generating events, and this telemetry is being sent through an event pipeline to something like a SIM or a data lake, where you're ingesting this information, transforming it, indexing it, and finally presenting it to an analytics engine so you can query this data, right? So at the end of this complex process, we can query the data, all this telemetry from all this and all this visibility into a we can create queries, and it could be, you know, a SIM query language, maybe Sigma, Jupyter notebooks, and then we can start detecting suspicious things in our environment running these queries, right? So deploying something like this is a challenge by itself, but I want to talk about a different challenge, and that is once you've spent all the time deploying this, one of the challenges that we have in environment is that environments are always under constant change. You know, software upgrades, firewall changes, ACL changes, maintenance windows in general. So what if one of these changes breaks something in this complex environment? So for example, what if one of your network updates in this part of your network somehow prevents your system from sending your Windows event forwarding, for example, event pipeline to your SIM or to your analytics engine. So if something happens in this part of your network, since you don't have the visibility, you will miss detecting that, right? So that is the challenge. So how do we address this challenge? Well, there's several ways, but I think for me, the most important way is adversary simulation. So, you know, we can simulate adversary techniques, execute adversary techniques in different parts of our network. And if the proper visibility is in place, if the event pipeline is working as expected, this telemetry created by the execution of malicious behavior will eventually make its way through the analytics engine, and then the detection should trigger, right? So by running simulations in your endpoints in different parts of your network, we can make sure that our detection program is working and operating as expected, okay? So this is what PurpleSharp does. PurpleSharp is an open source adversary simulation tool written in C# that will execute adversary techniques within Windows Active Directory environments following the attack MITRE framework. I think that PurpleSharp can help teams in building new detections, testing existing detections, validating detections resilience, identifying gaps in visibility, identify gaps with the event pipeline, and also, why not, verify the prevention controls. So by generating this telemetry, we can do all these things and identify issues in our detection program. So there are already adversary simulation tools out there. Why PurpleSharp? Well, I want to talk about 5 points that I think make PurpleSharp different. One is simplicity. So you don't need VMs or command and control communications or command and control implants. It's just one .NET binary that we need. The next one, deploy remote simulations. I think it's really important for us to be able to deploy simulations on hosts that are remote to our office or where we're running the simulations from. I have seen simulation programs or run from always the same fixed infrastructure. And if we do that, I feel like we're not testing end-to-end because you're assuming that the event pipeline is working. So if we're able to test simulations on remote endpoints, on remote parts of our network, we can confirm if the event pipeline is properly working in that part of the network. Credible simulations, PurpleSharp implements techniques so that the simulations actually run under the context of a user that's logged in on that endpoint at that point. Not only that, but it also runs the simulation from a path of that user's profile. So creating these credible simulations with real users and real process tokens help us really train the SOC instead of the alerts always coming from the same repeatable sources. Randomness. PurpleSharp is able to leverage LDAP and talk to your domain controller to actually pick random targets on the network to run simulations against. So that way, once again, we can run simulations against hidden parts of our network or parts of our network that we don't typically look at so that we can confirm that detection is working end-to-end on any part of our network. And attack variations. One really important requirement for me was to try to execute the same technique in more than one way. And I feel that this allows us to test detection resiliency. It's not the same thing to execute the PowerShell technique calling PowerShell.exe or running using .NET and System Automation Management DLL to execute PowerShell scripts without calling PowerShell.exe. So for as much as I can, I've tried to implement the same technique in many different ways so we can confirm that our detection is resilient. I'm not going to describe how PurpleSharp is able to accomplish this. Because of time, I want to use more of this time to show you the demos instead of talking how PurpleSharp works. So please read the documentation that you can find on this URL. But at a high level, this is how it's going to look like, right? You can instruct PurpleSharp to run a simulation against a host by defining the remote host. And PurpleSharp is going to use like Windows native features to deploy simulations on these random hosts. If you actually PurpleSharp can actually also pick random hosts. So you just define the domain controller and a parameter, and PurpleSharp is going to do LDAP queries and randomly pick hosts and run simulations against them. So once again, go back to the documentation to really understand how the deployment goes. Okay, so now we'll move on to the demos. Hello everyone, I'm Mauricio Velazco, and in this video I'll go over the first demo of the adversary simulation tool that I'm presenting at BlackHat Arsenal 2020 called PurpleSharp. In this first demo, I will use PurpleSharp to simulate two tactics of the ATT&CK MITRE framework: execution and persistence. As part of the attack lifecycle in an intrusion, adversaries will most likely engage in these two tactics to achieve their goal. I picked these techniques as they're commonly used by adversaries. If you want to learn more about this, you can go to the ATT&CK MITRE's website, and where they list out all the reports, open source reports they have found where threat actors and malware authors are using this technique across cyber espionage and cybercrime. The techniques are PowerShell, Visual Basics, Schedule Task for execution, and for persistence we're going to use Windows Service and WMI Event Subscription. Okay. Before I start the demo, I'd like to start with a question. Like, if you are a blue teamer and your team is monitoring their environment, we know that these are common techniques used by adversaries. So the question is, how do you know, how can you confirm if your team, if your SOC, if your MSS P is detecting these techniques? One way of doing this is through adversary simulation, and today I'm going to do it with PurpleSharp. Before I jump to the demo, I just want to quickly describe the lab environment that we're going to be executing the simulations. We have a domain environment, a Windows domain environment with a few hosts, and in this domain environment, we have configured Windows event subscription. And all these logs are being sent to Splunk, so we're getting Windows event logs and Sysmon events. The simulations will be executed from an endpoint that is not part of the domain. Okay. All right. So we'll jump to our lab environment. So we have here our operator computer that has PurpleSharp, and we have Ubuntu and a few other Windows boxes. Okay. So for the first demo, we'll execute PowerShell technique. I'm not going to describe the parameters or how PurpleSharp works. So please go refer to the documentation to understand that. So in this case, I'm going to execute a technique against Windows 10-1, so this host. I'm going to use the user P#. Remember that this user needs to be a local admin on this endpoint. This is the password for the user, the domain, and finally the technique. So PurpleSharp will upload the scout to this path because since we didn't define one, it's going to use the default one. It's going to execute the scout and connect to it via name pipes. The scout will retrieve some recon. In this case, it identifies that the user M. Simpson is logged into this host as as you can see here, March Simpson. Based on that, the PurpleSharp will upload the simulator in a path within this user's profile. In this case, the downloads folder. Then PurpleSharp will pick a process to use for the simulation. In this case, we're using the parent process ID spoofing technique so that our simulation looks credible, and it's going to be a child process of Explorer. This is what you get back when you run the tool. First, we have a header where it states the technique that we're using against the host it's running from. We also get the path where the technique is running from, the process ID, and then the context of the simulator the simulator is running under. In this case, it's March Simpson. So as you can see, PurpleSharp is running the simulation under the context of the user who's logged in here on this host. Okay. So we see some logs for this particular technique. In this case, it's going to execute this particular command with this encoded PowerShell command. It starts this process ID and it finishes. As you can see, I also added here detailed timestamps so we can correlate that with our logs. Finally, PurpleSharp cleans up after itself. So if we go to our logs here, we can see that we're getting events from our endpoints on our Splunk environment. And in this case, I'm going to look for logs in the past 5 minutes from this particular host. Oh, wrong one. And as you can see here, I'm going to sort by time. As you can see here, we see a 358 scout running, and the scout runs from this path. And actually runs under the context of P#, which is what I'm going to call the service account that I'm using to deploy the simulations. And after that, you see the simulator running, which is running from a path within the user profile, right? In this case, the downloads folder of March Simpson. And it's running under the context of March Simpson. So once again, this is one of the benefits of PurpleSharp, being able to deploy simulations that run in the context of actual users, so we can create credible simulations and train our SOC or test our detection. As you can see, we see PowerShell running with this encoded command. Okay, so the question at this point is, Do you have the visibility to detect this attack? Did you get an alert when someone executed this? Well, PurpleSharp can easily allow you to do that. One important thing as I was building PurpleSharp for me was the ability to execute different techniques. And PurpleSharp will actually execute the PowerShell technique in two different ways. One of them is going to be just use the Windows 32 API called create process just to execute PowerShell. But then another way of doing it is executing PowerShell encoded command using .NET and using PowerShell.create and invoking it. So this is going to look different on the logs. So you may be able to detect one way of the PowerShell technique, but maybe not this one. And PurpleSharp will allow you to test both. Okay. Okay, so we're going to move on to run the next simulation. In this case, we are going to run this with PurpleSharp. Let me explain this real quick. So we're adding a couple of parameters. First, we're going to execute the Visual Basic and the schedule task techniques together. We're defining the path for the scout. In this case, we're going to make it look like as if it's PSExec. We're defining also the path of the simulator to make it look like as if someone downloaded iTunes. And we're going to add this PB sleep parameter, which defines that it's going to execute these two techniques in a chain, but it's going to wait 15 seconds between one and the other. Okay. As you can see, we're running it against a different host, this time Windows 10-3. And in this, we see that the scout is being uploaded to a different path. We see that in this case, we find the user H. Simpson logged in, and PurpleSharp would then upload the simulator to the download folder and the iTunes file as we define. And it's going to once again execute the technique using parent process ID spoofing. So we will a few seconds for it to finish. So it does finish, and now we see the result. So as we can see, it first executed the technique, the first technique, Visual Basic, by running this command, and then exactly 15 seconds later at 4:04:28 seconds, it starts the second technique. In this case, it's going to execute create a malicious schedule task with this command line. We once again get the process ID, where it's running from, under which context. So we'll go back to Splunk and see those logs and see how that looks like. Okay. And we'll update here the name of the host, which is Windows-3. And as we can see, if we sort out, as we can see once again, we see the scout running from this path under the context of the service account P#. Then we see iTunes running. Then we see this execution of this what looks to be a potentially malicious BBS script at 4:04:13, and 15 seconds later, the schedule task is created and then deleted, as you can see. So PurpleSharp will clean after itself. So once again, the question I will ask you is, can you detect these techniques? Well, the only way of knowing is by testing them, and you can do it with PurpleSharp. So moving on to the demo, now I'm going to execute a different technique. In this case, I'm going to create a malicious service with PurpleSharp. Okay, so we're going to run that. We're just going to use the default scout and simulator path. And it's going to run against Windows 10-2 now. Now, because this technique requires a high integrity process, the scout will actually pick a process in high integrity to run this technique. In this case, winlogon.exe. Otherwise, we will not be able to create the service. In this case, we create the service with the command line using the sc commands, as you can see here. And it is run at 4:07:17, right? And then it deleted itself. So if we go to Splunk and we look for events of a service being created, you can find you can find here the event that happened at 407.17, as we saw on PurpleSharp logs, where this service, updater service, running from this weird path, was installed on Windows 10-2, right? So once again, really easy way of simulating an attack with PurpleSharp. Okay. And following the design of trying to execute the same technique in different ways, PurpleSharp supports two ways of executing this technique. One is the one we just executed using the command line and just the sc create command. But as you can see on this other one, it also supports creating a service using the Windows 32 API create service function. So first it's going to use OpenSC Manager and then create service. So maybe you can detect it in one way, but maybe not the other. So you can use PurpleSharp to confirm that. Okay. Okay. And then finally, we're going to execute one last simulation. This case, we're going to create a malicious WMI subscription. And I'm going to add an extra parameter here, no cleanup. So by default, PurpleSharp will clean after itself. So if it creates a service, if it creates a scheduled task, if it creates a user, it will delete them. But with this parameter, we're going to leave them so we can confirm that the WMI subscription was created. Okay, so we're going to run this against Windows 10-2. It's going to follow the process again. It's going to pick a high integrity process because this technique requires high integrity. And as you can see, I'm going to log in. Okay, so as you can see on the logs, it created a malicious WMI subscription using system management .NET namespace. It created a command line event consumer. It created the filter to consumer binding. And because we add the no cleanup parameter, it's not going to delete it from that host. So we leave it there. So if we go to that host and we go to PowerShell and look for that, we can see that this event subscription was actually just created. And in this case, it's gonna just execute PowerShell. This is a common way for attackers to obtain persistence, and the code will actually run a system. We just able to simulate a malicious WMI subscription with PurpleSharp. So this ends demo number 1. I'll see you on the next one. Okay, hello everyone. So in this video, we'll continue with the second demo of PurpleSharp Adversary Simulation Tool. So in this demo, we'll go over two new tactics, discovery and defense evasion. So as an attacker progresses on a breach, they will most likely engage in these tactics to obtain information about the environment or bypass controls. So in this case, as far as discovery, we'll go network share discovery, network service scanning, and then domain account discovery. And then for defense evasion, we'll execute process injection simulations, particularly portable executable injection, as well as clear Windows event logs. As a reminder, we are executing these techniques in a Windows domain environment from a non-domain joined computer, and all the data is going through Splunk, which we're gonna review. Okay, so we'll jump straight to the demo. So in this case, we're going to execute the demo in a different way. So as I was writing PurpleSharp, I reached out to the community and friends to get some feedback, and Olaf Harton gave me an interesting feature request. So we needed a way to execute playbooks without using the command line, and instead using something more flexible that maybe could allow you to automate things. So I came up with this feature of executing playbooks using JSON files. So for more information about the syntax, please go to the documentation. But this JSON file will execute two simulation playbooks. The first one against Windows 10-1, and it's going to execute two techniques. It defines where we're going to upload the scout and the simulator. It's going to wait 30 seconds between each of these techniques. And And then on the second simulation playbook, named Discovery Simulation Playbook number 2, we're going to execute it against Windows 10-3, defining different paths, and then we're going to execute the account discovery technique. Okay, so we'll go to PurpleSharp and pass the PB parameter with the JSON as the parameter. It's going to ask us for the password of the account. Okay, so it's going to start executing these two playbooks. So I'm going to stop the video for the sake of time and come back once it's finished. Okay, so it finished. So we'll go back app, and as you can see, it first executed the first playbook, executing two techniques against Windows 10-1. It provides similar headers and information about the techniques as we have seen before. Then it waited 1 minute for the next playbook as per our JSON that wanted to wait 1 minute. And executed the other technique against Windows 10-3 and finished, and it also wrote the results. So we're gonna open the results on Notepad++. So we see here the results, and then we're gonna use this to format the JSON. So as we can see, we received the results of these simulations here in JSON file, which makes it really easy to ingest, right? In this case, we see that the simulation ran under context of M Simpson. It ran under this path with this process ID, so we can always use this information to correlate with our logs. And then each task will have some results. In this case, it was successful, the network share enumeration. We get the time, and we can see some debug events for debug messages for each this technique. In this case, it's using the Windows 32 API netshare enum to enumerate shares. It query LDAP, randomly picked 7 targets, and run the network share enumeration against these targets, which we'll see in a bit. And then it executed the port scan technique. It was successful. It used system.net set sockets. It once again obtained 7 random targets on the network and scanned them. Okay, so let's see what the looks look like for this. Okay, so for this first network share discovery, we're gonna go to Splunk. In this case, we're gonna use the event 5140. Actually, okay, I had to change the query a little bit. So in this case, we're looking for 5140s from the address of 151, which is Windows 10-1, which is where we run the simulation from. And as you can see on the events that we just got for 10.06, we were able to correlate what PurpleSharp did, and on this host, they were enumerated, and as we can see here, the IPC $ share was accessed from against this host from our Windows 10-1. So once again, if you want to build a detection for an attacker maybe trying to enumerate shares, you can use PurpleSharp to obtain the telemetry and maybe test or create your detection. Okay, and for the next simulation, in this case, the port scan, as you can see, it ran at 10.07. PurpleSharp was able to run a network scan or a port scan against this host. So if we go to Splunk and we use event code 3 from Sysmon, we're going to see some interesting events. So as you can see here, this the simulator that was running under the context of Mark Simpson under this path actually port scan against RDP and 445 against all these hosts. So if you have Sysmon, you could create a rule to detect an endpoint doing network port scanning, or maybe if you have network telemetry like NetFlow, you could also try that and use PurpleSharp to see if your detection is working, or maybe you have some kind of NTA, network threat analytics. You could also test that. Okay, and then The last simulation of this playbook was just an domain account enumeration. In this case, we see that the net user slash domain command was executed. This is typically used to discover who is who in the domain, and we can see from the logs on Ubuntu once again that first we had the service, the scout running, then the simulator running, and then the net commands executing here. Now, one interesting thing is that PurpleSharp can execute this technique in two different ways. We executed one of them, which is like the simple net user slash domain, but there's a more interesting one that I have implemented that uses LDAP. It runs LDAP queries to execute the account discovery. So you may be able to detect the first one with just Sysmon or some kind of EDR, but maybe for the second one you need something more on the network, like maybe an ATA or a tool that is sniffing for LDAP traffic. So PurpleSharp will be able to test both. Okay, and for the next simulation playbook, we're going to execute this second JSON file. In this case, we're going to execute this technique, which is process injection. And then we're going to clear the event log. The first one runs against Windows 10-3 and the second one against Windows 10-2. Okay, so we're gonna give that a try. We're gonna pass this. We're gonna, oh, that doesn't exist. Okay, so I'm gonna stop the video and then come back when it's finished, when PurpleSharp is done. Okay, and it just finished now, so we see the results here. So we're gonna open up the results JSON file to review that. So it's gonna go here, and we're going to format the JSON. Okay, so as you can see, the first playbook executed against Windows 10-3, it executed one technique, which is the process injection. And on the debug logs, you can see what PurpleSharp did. It first started a process, notepad.exe, and then it called the typical Windows 32 API calls to inject malicious code, open process, virtual alloc, write process memory, and create remote thread against this process. So let's see how that looks like on Sysmon. So we're gonna run this query. No, we don't want this. And we're gonna sort by time. Okay, so as we can see here, this actually runs. So let's check on the times. So this was at 10:19, 10:18. Let's take a look at this. So as you can see, it matches the times. So first we see the scout agent running once again. You can see that the simulator is running, and then you can see here event ID 1 for process starting. Event ID 8 is on Sysmon create remote thread. So as you can see, the source image was the simulator tmp12345.exe, and then it injected code into notepad.exe. So we successfully detected this injection, and in this case, the shellcode that we injected, all it does is just executes a simple ping command. So with PurpleSharp, we have been able to easily simulate a process injection, and with Sysmon we can detect it. So again, the question is, can you detect these attacks if they run against your network? And one easy way of doing that is testing that it's using PurpleSharp. And now we're gonna run one last query. We're gonna run this query, and on the results of the playbook, we see that the second playbook executed again Windows 10-2 running as system, and then it deleted security event log using the command line. In this case, use the command line. And as we can see here, around that time, we can see this event 1102 where the audit log was clear, the security log was clear. So once again, PurpleSharp allows us to simulate an attack in a real computer with real users in a really easy way. And one last thing to mention, again, I would want to be able to execute the same technique in many different ways, or at least in two ways. So I can do clear event logs using the command line, just like as we did with this command. Or we can also use .NET, and in this case, we're going to use just event log .clear and close. So can you detect both, or just one, or none of them? You can use PurpleSharp. Okay, so this concludes demo number 2. Okay, so that concludes our demo number 2, which actually also concludes the presentation. As a reminder, I didn't have enough time on this presentation to go over how PurpleSharp works and some of the other features it has. So please refer to the GitHub page or the documentation to learn more about it. So this concludes my presentation. Thanks a lot for coming in this virtual setting. As always, that's my Twitter account. If you have any questions or feature requests for PurpleSharp, please let me know. Thanks everyone.